A blessed morning to you, my dear RC1 students. Ang lecture natin ngayon ay Design of One-Way Slab. Remember na sa two-way slab, kapag ang ratio ng LB all over LA is greater than 2, kailangan one-way slab ang gagamitin nyo. So dito tayo ngayon sa one-way slab. Ang pattern ng input data para rin lang yung sa two-way slab. Okay, so we have the concrete and steel properties, and then the live load, tapos superimposed dead loads, and then the main bar, temperature and shrinkage bars, and then the constants, and then we have the effective depths, and then the weights towards the ultimate weight W sub U. And then we have the same equations for maximum spacing for main bar and temperature and shrinkage bars. So, number 1 is identify the type of slab. And then second, compute minimum thickness and check. Okay, so this is found on page 3. But before going there, dito tayo sa general equations. So we have coefficient. Take note na this is very similar to coefficient method. Yan yung letter C. So meron siya sa page 3 mamaya. This is also the same equations with two-way coefficient method. So kailangan natin ng constant, and then we have MU, RU, required draw. And then very similar also to two-way. If your computed draw, or that is your required draw, is greater than the raw minimum, then okay. Ang gagamitin nating raw is equal to your required draw. But then if your computed draw, again, that is your required draw, ito, is less than the raw minimum, then you have to recompute your raw. That is the maximum of these two equations, raw min and 4/3 of your required draw. And finally, if your required draw is greater than your raw max, ibig sabihin masyadong malaki yung moment mo, hindi kaya nung slab. So that means fail. You have to increase your thickness or your concrete and steel properties. And then after determining your raw, you have to compute your required spacing. Tapos, mag-round down ka by 10 mm. And then that is your final S, or use S, required S, or maximum S main bar. Okay, maximum S main bar, nandun yan sa page 1. Now, let's go to the detailing. Yung bar number 1, ito yung nasa continuous edge, top bar. Bar number 2, yan yung bottom bar. That is the positive moment. And then bar number 3, that is negative moment, nasa discontinuous edge. And then itong bar number 4, yan yung mga temperature and shrinkage bars. Inilalagay lang natin yan sa ilalim, or that is the bottom bar. The entire span, lalagyan mo yan ng temperature bar. Now let's go to page 3. Types of slabs, minimum thicknesses, and moment coefficients. First, dito tayo sa exterior slab. So, ganito ang kanyang figure. Take note na itong bakal, lumampas siya dito. Ibig sabihin, merong slab dito. Okay? Which is, yung exterior slab, ganito ang kanyang figure. Okay? So, ito yung continuous edge. Dito naman sa kabila yung discontinuous edge. So, take note, bar 1, ito yun. Yan. Tapos, bar 2, positive moment. Yan. Tapos bar 3, nasa discontinuous edge. Ito. Okay, so ang coefficients para sa bar 1 is 1 over 10. If you're using 2-span, that means dalawang slab lang yan na or dalawang exterior slab na magkatabi, kagaya nito, number 6, 2-span. Ang gagamitin mo ay 1 all over 9 ang coefficient. Next, para sa bar number 3, sa discontinuous edge negative moment, ang gagamitin mo ay 1 over 24. And then for bar number 2, that is bottom bars, your coefficient is 1 all over 14. Tapos yung minimum H or minimum thickness, that is equal to F times LU all over 24. LU is the unsupported length. Okay, so that means center to center ng beam minus half of this beam minus half of the other beam. Next, we now go to interior slab. Interior slab simply means continuous siya on both edges of the beam. So, continuous dito, continuous din dito sa kabila. Yung bar number 1 mo, tumagos, and then tumagos din sa kabila. So, definitely, walang bar number 3 dito sa interior slab. So, sa negative moment, you have 1 over 11. Tapos sa positive moment, 1 over 16. And then, this is the minimum thickness. F times LU all over 28. Ngayon, yung capital F na yan, that is dependent on your Fy. For Fy less than 400, your F is equal to 1. Otherwise, kung yung F mo greater than 400, yan yung nasa grade 16 na rebar, your F is equal to 0.4 plus Fy all over 700. So, yan ang computation ng F. Next, we now go to slab number 3. Okay? Or type of slab number 3, simply supported slab. So, basically, wala itong negative moment. Positive moment lang or bar number 2 lang. So, 1/8 ang kanyang coefficient. This is very similar to the moment equation of a simply supported beam. That is 1/8 times WL squared. Okay? And then for cantilever slab, negative moment lang ito. Walang positive moment. Take note na ang moment ng cantilever slab is WL squared all over 2. Yan yung kanyang coefficient, 1/2. And then number 5, exterior slab, this time it is unrestrained end. Ibig sabihin, dun sa end, simply supported siya. So, walang negative moment dito. Walang bakal na ilalagay. Walang bar number 3. Okay, so sa continuous edge, you have 110 mid-span, 1 all over 11. Dito sa taas, 0. And then finally, we have number 6, 2-span slab. Ibig sabihin, dalawang exterior slab na magkatabi. In short, ito walang interior span na slab. Take note, ang pinagkaiba lang dito, yan, 1 all over 9 compared dito 1 all over 10. Tsaka yung mid-span, 1 all over 14. And dito sa kabila, 1 all over 11. Ito naman yung nasa mga textbook, which is basically the same as this. For example, dito sa exterior slab. So, yung dulo niya, this is restrained. Okay? It is not simply supported. Ganito. So, restrained simply means integral with support. Ibig sabihin, monolithic yung buhos niya, merong moment. So, ang coefficient nung positive moment or yung bar number 2 is 1 all over 14. Ito siya. And then, sa negative moment naman or yung mga top bars, para sa restrained edge, integral with support. Yung kanyang coefficient is 1 all over 24. Ito, which is this. And then, sa continuous edge, 1 all over 10. Yan. Now, let's go to interior slab. So, ang sample ng interior slab, ito, positive moment is 1 all over 16. Yan. Tapos, negative moment naman, 1 all over 11 kabilaan, which is, ayan. Tapos, sa number 3 naman, simply supported, wala na dito yan kasi panay continuous slab ang ginamit dito. Okay? So, 1/8 WL square all over 8. And then, case number 4 naman, wala rin dito yan dahil ito ay cantilever. And finally, exterior slab number 5, merong unrestrained. So, dito tayo sa simply supported. So, ang positive moment niya is 1 all over 11. Ito. And then, ang negative moment niya is 1 all over 10. Yan. And finally, kapag 2 span, ang gagamitin mo ay 1 all over 9. Yan. Next, we have the bar cut-off details. Or simply, saan tayo magpuputol ng bakal. Sa negative bar or bar number 1, kailangan i-extend mo yan at LU all over 3. Tapos, sa bar number 2 naman, mula dito sa edge, ang supported edge, that is LU all over 8. Dun ka maglalagay ng bakal. Sa top bar naman, sa discontinuous edge, mula dito sa face ng support, mag-extend ka sa LU all over 4. Tapos, dito naman, LU all over, this is interior span. Yung top bar mo, on both sides, kailangan mag-extend yan ng LU all over 3. Tapos, sa positive moment naman, or bar number 2, that is, mag-start siya sa LU all over 8 on both sides. And then, finally, para sa exterior slab naman, kung unrestrained edge yung dulo, mag-start ka sa LU all over 8 and then tuloy-tuloy na yan dito. Tapos yung top bar mo, mag-extend siya LU all over 3. Which is basically, ito pa rin. And then let's go to a sample design of a one-way slab. So, ang kanyang unsupported length is 3.1. Ang type or case of slab is 1. That simply means exterior slab siya. Restrained on end. Okay? Ito siya. Case 1 or type 1. Ito. So, meron siyang bars 1, 2, 3. Ang coefficients natin ay 110, 114, tsaka 1 all over 24. And then, ang kanyang minimum H is F times LU all over 24. Okay? So, ayan. Tapos, ang unsupported length niya, 3.1. That means, mula dito sa face ng support hanggang sa other face of support. And then, floor finish, 1.8. Ceiling and utilities, 0.4. Mapapansin nyo na walang 1 kPa na partition load. That is because ang assumption ko dito, hallway siya. Also, kapag hallway, daanan yan ng tao. So, ang live load mo ay 4.8. And then, diameter of bar is 12 mm. Diameter of temperature and shrinkage, 10 mm. Tapos, we have constants, beta, Romax, Romin, Rho-G, and finally, we have effective depth D, which is 104. Yung effective depth D, that is thickness. Yung thickness mo pala, yun, 130 mm. So, your effective depth D is thickness minus clear cover minus dB all over 2. It will give you 104 mm. And then we have dead load. This is superimposed dead load. Okay? Superimposed dead load plus self-weight. Ngayon, yung superimposed dead load is ito, yung 1.8 tsaka 0.4. And then, yung self-weight na 0.13, 23.6. Yung 0.13 na yan yung thickness times your unit weight of concrete, or that is 5.268. And then, your ultimate load is 1.2 times dead plus 1.6 times live. That is 14.00 something. You store that to letter A of your calculator. And then, using the following equations, maximum spacing for main bar, yan, you will get 260. And then, maximum spacing for temperature and shrinkage bars, ito, you will get 300 mm. Your minimum H is F times LU all over 24. So, ang LU natin is 3.1. Tapos, ang F natin ay 1. Dahil ang Fy ay less than 400. So, lumalabas na ang ating minimum H is 129.17. Ang ating thickness ay 130. So, that is greater than your minimum H. So, therefore, okay.